Hi, welcome to EasyPeazMaths class. Today we are going to start with exercise 1.2 examples. But before starting with examples, let's understand this theorem. What it says, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. What it says, P is a prime number and A is any positive integer. Let's understand this theorem by taking an example. Suppose 2 is a prime number and A is any positive integer. Let's say it's 4. What it says, if P divides A square, if prime number is divisible by square of any positive integer, which is true, then it is divisible by A also. That's correct. If P divides A square, then P divides A also, which is true. Here check. 16 is divisible by 2. Then 4 is also divisible by 2. So exercise 1.2 questions are based on this theorem. Here is the exercise 1.2 examples. Question number 1 is prove that root 2 is irrational. Here is the exercise 1.2 examples. Question number 1, prove that root 2 is irrational. Suppose root 2 is a rational number where A and B are co-primes. What are co-prime numbers? Co-prime numbers are those numbers whose HCF is 1. Right? Can we write this number as root 2b is equals to A square? Both sides we get A square. 2b square is equals to A square. So what you observe here? A square is divisible by 2. 2 divides A square. Therefore, 2 divides A also. Yes? Make it equation 1. Let A is equals to 2C for some integer C. Put the value of A in equation 1. We get, अगर आप इसको A की वैल्यू को पुट करोगे इस इक्वेशन में, what you will get? 2b square is equals to 2c whole square. Correct? Which is equals to 2b square is equals to 4c square. B square is equals to 2 square because this cancel out. Right? Here what you observe? 2 is divisible by B square. 2 divides B square, then 2 divides B also. Make it a second equation. From 1 and 2, what we observe? From 1 and 2, 2 is a common factor in these two cases. 2 is a common factor. Therefore, contradicts our assumption hence root 2 is irrational. Question number 2 is prove that root 3 is irrational number. Suppose root 3 is a rational number where a and b are co-prime numbers. Co-prime numbers are those numbers whose HCF is 1. Can we write this equation as root 3b is equals to a? Square both sides, we get root 3b whole square, a square, we get 3b square is equals to a square. So what you observe from this equation is a square is divisible by 3. 3 divides a square, therefore 3 divides a. Make it first equation. Let a is equals to 3c. For some integer c, put the value of a in equation 1. In this equation, we get 3b square is equals to 3c whole square, 3b square is equals to 9c square, b square is equals to 3c square. Here what you observe? b is divisible by 3. 3 divides b square, therefore 3 divides b also. Make it second equation. From 1 and 2 we get 3 as a common factor. Therefore, this contradicts our assumed assumption. Why? Because what we assumed, a and b are co-prime numbers, can having a common factor of 1 only. But what we get at the end, 3 as a common factor. So hence our assumption is contradicted. Therefore, root 3 is irrational. Question number 3. Prove that 5 minus root 3 is irrational. Suppose 5 minus root 3 is a rational number where a and b are co-primes and can we write this equation as 5 minus a minus b is equals to root 3, which is equals to 5b minus of a upon b is equals to root 3. Yes, if 5b by minus a upon b is rational, therefore root 3 is also rational as per the equation number 1. But root 3 is irrational. Also, rational number cannot be equal to irrational number. Yes? So here contradiction has arisen. What we assume that 5 minus root 3 is a rational number. But here root 3 is a irrational number. Therefore, this contradicts our incorrect assumption that 5 minus root 3 is rational. Hence we conclude minus root 3 is irrational. Question number 4. Prove that 3 root 2 is irrational. Assume 3 root 2 is a rational number where A and B are co-primes and B is not equals to 0. Rearrange these values. What we get? Root 2 is equals to A by 3B. Yes? So from this equation what we observe? A by 3B is a rational number. So root 2 is also a rational number. But root 2 is irrational. Also, rational number cannot be equal to irrational number. Therefore, this contradicts our incorrect assumption that 3 root 2 is rational. Hence, we conclude 3 root 2 is irrational number.